Hello and welcome to the lesson on 6.6. We're going to be talking about linear inequalities now. We've talked about linear equations already, but inequalities are a little different. We've got these greater than or less than symbols, or less than or equal to, greater than or equal to. So you should know what these two things are by the time we're done with this lesson. And let's just hop right into some examples here. So I would imagine, if you're in my class at least for CTM, you've seen stuff like this before. Hopefully this will be a good review for you as you continue with your mathematical lives, careers outside of this class, and hopefully you can actually apply this at some point in your life as well. So if you're not applying this directly, at least you're applying the knowledge and the insight and the thinking and processing skills that you're gaining by doing this in mathematics in general in your real life. You're a problem solver. So solve the inequality 2x plus 14 is less than 20 and graph the solution set on a number line. So let's do that here. Here's my solution. So let's start off with the same inequality. It's an inequality because it's not the equal sign right here. We've got a less than sign instead. So 2x plus 14 is less than 20. And these, again, are solved the same way as equations. So treat it exactly the same. Treat it as if this were an equal sign right here. So I'm going to subtract 14 right here and right here. By doing that, let's use our different color for that. Let's have that canceling out. So just like if this were an equation, inequality the same way. We are only going to be switching the signs when we do one specific thing. Right now I just subtracted, so that doesn't switch the sign. Maybe you remember what I'm talking about. Maybe you've never done a problem like this before. So just hold tight. Either way, if you think you know when you switch the sign, just keep it to yourself right now. Okay, thank you. And we'll see if you're right in a little bit. So divide by 2. Again, solve it the same way as if it were an equation, but just keep carrying that sign down. We didn't do anything to switch the sign around, so this would be 3 right here. So this, yes, is part of your final answer, but it also says to graph the solution set on a number line. So we're going to draw a number line, and we're going to we'll put 0 over here because I want to go positive 3. So I'm going to go out 1, 2, 3. Notice I'm not using a ruler to measure these things, but I did the best I could to just using my eyes to make sure that this scale remained the same as I went out this way. And now what do we put right here? If you've taken algebra before, you should remember hopefully that it's going to be an open circle right here. So you're not going to fill that in because you don't have or equal to. That's a visual way of representing that it can't actually be that. So it's an open circle, not filled in. If it was filled in, that's saying yes, it could be that number, but it's not filled in, so it can't be that number. And we're saying that x, let's put an x here, since this is representing x values. X can be anything that's less than 3. So as I move to the left, these are potential values. These are all values less than 3. As I move to the right, though, these are not potential values because they're not less than 3. So we are going to shade in or thicken in this part right here to the left of the open circle and then put an arrow there. We can't continue on the lines forever. We don't have enough paper for that. We'd be going to the moon and then quite a bit more. We just continue on into the outer edges of the universe. Is the universe infinite? The last I heard, that's up for debate still. I don't know. What do you think? I think the physicist is probably who we want to talk to about that one. And I am not a physicist, but I've taken some physics classes, and I found them very interesting. And I'm just going to finish the problem now because I am totally off on a tangent. We are using an open circle because it's not or equal to. Okay, so there's no or equal to part underneath there. So we're going to use an open circle. So make a little note of that in your different color right there, pointing to this dot right here. And then pointing to the shaded part of the line, any value on the shaded part is a possibility, or in other words, a solution. So any value on the shaded part is a solution. So a value right here would work. Value out here would work, because remember, this just keeps going on and on forever. The value right here is fine, here is fine, here is fine, but as soon as you get right on 3 or above it, no longer okay, no longer a solution, something that won't make that true anymore. Let's check out example 2 now. So second example, now I'm going to throw in one little twist here. We're going to have to solve a little bit more here first. So solve the inequality. -4 times the quantity, I'll enunciate my first T there, not equals, I'm sorry, we're dealing with inequalities. This should be less than or equal to is what I wanted to say, less than or equal to 68. And once again, we're going to graph the solution on a number line. Let's check it out. What are we going to do? Let's start by rewriting the inequality. -4 times the quantity x plus 10 less than or equal to 68. Now I'll take your different color to show the steps here. We're taking -4, not just 4, but -4, and distributing that to both parts here and here. So you have -4x minus 40 is less than or equal to 68. So good so far. I'm going to add 40 to both sides, trying to get x by itself, just like I would if it were an equation. But inequalities, again, we solve them exactly the same. There's just one little twist. And here comes that little twist. So what's the little twist here? Well, I'm going to divide by a negative value right here. Before I was just adding, I was multiplying through by the negative, but I wasn't doing the same thing to both sides of the inequality. Now I'm dividing both sides of the inequality by a negative value. That would cancel right here and here. That, though, is going to make the sign flip. We're not going to get into why the sign flips for right now, but just know that when you multiply or divide by a negative value, you are going to be flipping the sign. And so right here, this would be, this divided by this would yield -27. So right here, circle that part and make a little note of what we just did. Why did the sign flip? The sign switches, or flips, in other words, the sign switches or flips when you are multiplying or dividing. Multiplying or dividing by a negative number. And let's make our number line now. Now I really don't feel like drawing 27 different values, and so I'll show you a little shortcut that I'm fine with if you want to use that. I'm going to put my 0 out here. I know -27 would be somewhere over here, but rather than doing 1, 2, 3, 4 all the way up to 27, I'm just going to say that -27 is about there. Then you could fill in the rest of these if you wanted to. You could go by 5s if you wanted to. You could go by 3s if you wanted to, but as long as you have 0 somewhere and then the value in question somewhere, and you put those two numbers in there and they're in the right spot, 0 is more or greater than -27, so it should be to the right of that, then you'll be good to go there. And so for here, we've got less, or we got greater than or equal to. So it could actually be -27. Therefore, I actually fill that circle in this time. And we're talking about anything that's greater than or equal to, so we have to shade it to the right. And it would go on forever, so I'm going to put an arrow right there. So let's make a little note of that for this circle right here. We already said that anything on the shaded part in example 1 was a solution. That same thing holds here. but now we're using a closed circle. Pardon me. Getting over being sick. No fun. But glad it's finally over, because it is or equal to. Closed circle, because is or equal to. We have that phrase in there, we have that symbol right there. So or equal to, we're going to fill in that circle because that is a potential or possible value. Example 3 now. Let's check out, we haven't talked about compound inequalities yet. We're going to check that out at this point. And so solve the compound inequality. Let's underline that. That's a phrase that we should know. That's one of our vocabulary terms for this lesson. 4x. So compound, just meaning more than one, or we're going to have more than one symbol, greater than, less than, etc. So 4x and graph the solution set where part A, we're going to have x is a real number, and part B is going to be x is an integer. So I'm trying to kill two birds with one stone here. Not that I think you should kill birds necessarily, unless you're starving, dying for food, or you're just hungry for chicken. But solve the compound inequality for x. So compound meaning more than one thing. We're killing two birds with one stone here. It's just a phrase that is used to say we're doing two things at once. The book separates this into a couple of different examples, but we're going to talk about compound inequalities and graphing like this, which we've done already, real numbers and integers, how that looks a little different. So let's start with I haven't given you the inequality on this one. I'm going to tell you that this is what we're going to start with. So negative 1 is less than x plus 2 divided by 3, which is less than or equal to 1. So not only does negative 1 have to be less than x plus 2 over 3, but x plus 2 over 3 also has to be less than or equal to 1. That's what makes this a compound inequality. There's more than one thing that has to be true at the same time. And so what values are going to satisfy this? Well, this is what we're starting with. We can take everything to get rid of the fraction. The simplest thing would be to multiply by the denominator. So to multiply everything by 3. Let's do that here to start. So multiplying everything by 3, we can change, just like an equation, we could change all parts of the equation in the same way. In an inequality, we can change all parts of the inequality in the same way. So multiplying everything by 3 will keep the statement still a true statement. So we're going to have negative 3 is less than, this cancels with that, so we'll have x plus 2, which is less than or equal to 3. From here, I can subtract 2 to get x by itself. That's what I'm trying to do here. So subtracting 2 from all parts of the inequality is what I need to do there. That will cancel out there and there. And that leaves me with negative 5 is less than x, which is less than or equal to 1. That, my friends, is the solution in terms of an inequality, in terms of a written out statement like that. But parts A and B, we need to graph these on a number line as well. So let's make a number line right here. This is for real numbers. So we're going to say, let's put negative 5 over here and a 1 over here. And this time I want to draw these into scale as best I can. So I'm going to need to go to 0 and then have 5 equal spaces there as well. So it looks like about there would do that for me. 2, 3. So I've got negative 5. It's a less than, strictly less than, not less than or equal to. So it's an open circle right here. And then I have x is less than or equal to 1. So I'm going to have a circle, but fill that one in. It could actually equal 1. And I'm saying x is greater than negative 5, so it's going to be going this way, but it's also less than or equal to 1. So I'm going to be going this way with that. So the thing that would satisfy both of those statements at the same time, the values, the numbers that would satisfy both of those statements would be the ones in between negative 5 and 1. And again, it can't include negative 5, but it can include 1. And so that's not really new information there, just combining the ideas we've already seen. But let's draw the graph again for part B, and now we're just doing integers. How does that different, or how is that different? How does that vary from what we talked about? So I'm just putting in the values here. This is 1, 0, negative 1, negative 2, negative 3. Okay. And so now we're saying just integer values. So that's just the positive or negative whole number values, or 0 is also included in there. But it's not things in between these whole number values, positive or negative, in that manner. So can it be negative 5? Well, no, it can't be. And it can't be negative 4.99 or negative 4.5. Those are not integer values. So the first value I can have here, not 5, it's not negative 5, I mean, but it's negative 4. That's the first value that would be a possibility as an integer as I move from the left to the right. Negative 3 also works, but nothing in between there because it has to be an integer value. Negative 2 works, negative 1 works, 0 works. Does 1 work? Well, yes, it was a filled in circle here. It's a possible value as an integer as well here. Also, let's make a little note of this with this one, that only integer values work here. That's why we were just drawing specific dots rather than just shading in everything in between. So only integer values work here. And then I want to finish off with a very practical question, where we're actually going to use the stuff we're learning here to figure out something that could be very important to you, trying to figure out what your grade is and what you would need to earn on the next test, something like that, to get the grade that you're shooting for in the class, something like that. So here's the fourth example. Suppose you earned, not your, but you, here we go, suppose you earned scores. Notice I say earned, not the teacher gave me this. No, this is the score you earned. You received this score based on your performance, not on how much the teacher likes you or doesn't like you. So you earned scores of 77.5%, 69%, and 83% on your first 3 tests. So let's say that that is true. First time, what am I doing? First 3 tests. And the question here, what we want to know is what must you score on your 4th test to have an average test score of at least 80%. So I used to do stuff like this when I was a student. I would be like, okay, I've gotten this, this, and this so far. This is how my teacher's calculating grades. I'm aware of that. So what do I got to get on this final exam to pass the class with a certain letter grade, an A, B, whatever I was shooting for. Usually an A because I was striving for doing the best I could. So hopefully you strive for that as well. But what is our solution? How can we get this here? So let's say, we always want to say what our variable is representing. So we'll go with x, but x is going to represent or equal our score on the fourth test. That's the thing that could change. That's the thing that can vary here. So score on the fourth test. Then I know the average score, you're supposed to just add up the values that you have and divide by how many values there are. And so here, taking the average of 4 tests, I would take my first test, which was 77.5. Take that plus the second one, 69, plus the third one, 83, and plus the fourth one. The fourth one I don't know yet, so I'm calling it x again here. So that's going to be that over 4. That I want to not equal, so I got ahead of myself there. I want it to be at least 80%. So at least 80% would be greater than or equal to. As long as I would get that, I would get a B for my test average. So this right here, let's circle that and let's connect that to this right here. That's where this comes from. And then this part right here, let's circle this part in our different color and make a little note of where this came from. This was the average, AVG standing for average, the average of the 4 test scores. And so from here, let's simplify what I have in the numerator first. So this plus this plus this. If I add these 3 values together, combine like terms there, I've got 229.5. That plus x over 4 is greater than or equal to 80. From there, I can multiply both sides by 4. Let's do that in a different color here. So times 4 here, times 4 here, that'll cancel there and there. I'm left with 229.5 plus x is greater than or equal to 320. From there, subtract 229.5 from both sides. Notice I did not multiply or divide by a negative. I'm just subtracting right here. So the sign is going to stay pointing the same way. And that will cancel out here and here. If you were saying the x value would have to be less than or equal to a value, that really wouldn't make much sense because you're trying to get this score that'll assure that your grade is at least that much. So to flip the sign wouldn't even make sense intuitively either. So this, though, becomes, if we take this minus this, I'm going to get 90.5. So you're going to have to do pretty well on that final test. That means you have to get at least a score of a 90.5% to average a B average, at least for most places. That would be a B average, 80 or higher. So we're going to say, to finish this example off, therefore, you'll have to score at least 90.5. Not exactly 90.5. It could be exactly that, but it could also be more than that. If you got a higher score than that, you would still get at least an 80% average on your on your test average. So at least that on your 4th test. And that is going to do it for us. I feel like that is sufficient. Check out your book for some extra examples. Let's see how many they got. With this one, they've got 1, 2, 3, 4, 5, 6, 7, 8, 9. They've got 9 more examples in the book. Check those out if you need some extra help. Go back and review these as necessary as well, and hopefully you'll do well on the classwork. Let me know in class if you have any questions. If you're one of my students, have a wonderful day.